which is section 1.2, combining functions, shifting, scaling graphs. Okay, so here we have a couple of functions here. We add them, take the difference, multiply them, take the ratio, etc. And what's important here is it's easy to add them up. Like, for example, if you choose f as square root of x, g as square root of 1 minus x. Okay.
Yes.
1 second. Okay. Okay, so we have square root of x, we have square root of 1 minus x here. We are adding them up. We are taking the difference. And then we have the domains of each. What's the domain of square root of x? Let's open this up and talk a little bit on that. Okay, let's talk about that. We know from last week, the domain of square root of x are all non-negative reals. X is greater or equal to 0. We know that from last week. Okay. And then square root of 1 minus x has the domain everything less than or equal to 1. Why is that? Because inside function 1 minus x has to be greater or equal to 0. 1 minus x is greater or equal to 0 is the same as x is less than or equal to 1. Okay. So for these two different functions, we have different domains. But if I add them up, what's going to be the domain? Okay, can we combine the domains, and how are we going to combine the domains? Okay, so here 1 minus x greater or equal to 0, namely x is less than or equal to 1. This is the work we did to get this. Okay. Okay, maybe I should write y. Okay, and then answer. It's for you to remember. And then if you combine the two by addition, the domain is going to be just 0 to 1. Why is that? We just take the intersection of the domains. The intersection of this set and this set is going to give you 0, 1. And 0 and 1 are both included. Okay? Similarly, these guys, when you're taking addition, subtraction, multiplication, you are going to take the intersection of the domains. But when you take the ratio of the functions, you need more. You look at the denominator, and the denominator can never be 0. So you are going to exclude the point that's going to make the denominator 0. So it's going to be 0 to 1, but 1 is excluded. And similarly, if you look at the domain of g over f, what's the denominator? X, which makes the denominator 0, 0. So we have to exclude 0 here. Okay? That's the story of this page. If you have any questions, let me know. Just a sec. All right, so I'm back here. All right, these are the graphs of f and g added up. Okay, so obviously f is this much and g is this much, and if you add them up, it's gonna be bigger, assuming that f and g takes the positive values here. Okay, so pictorially you can see that this is the graphical representation of addition of the two, and this graph is, on the other hand, you see the addition of the two functions, square root of 1 minus x and square root of x. You're adding them up, and this is the product of the graph of the product of the two. Okay, and they are all on the same domain. Okay. All right. Let's see. Next thing is about composite functions. If you have two functions, you can take you can compose them. And the composition order is important. If you compose them, f compose g like that, okay, then you need to be careful that the domain and range, you have to be careful. For example, the domain of g, let's say x is in the domain of g, but you're composing it with f, so this would mean the range of g has to be inside the domain of f to do that operation. This is an operation, okay? The output of G, okay, has to be inside the domain of, okay, that's important. Another picture that shows it. So we have G, we have F, we compose F compose G. Here F compose G, X goes to G, G goes to F compose G, okay? That's how we will do. All right. Pictorial like that. Next, we are going to be talking about the shifts. Just one sec. All right. Shifting. We talked about shifting graph to the right, to the left, up and down. Now, which is this actually? This is called the vertical shift. If you add k to it, you are gonna shift the graph by k units. If k is positive, it's shifting up. If k is negative, it is shifting down. I mean, absolute value k units down. And horizontal shift, if h is positive, you're shifting to the left. If h is negative, you're shifting absolute value of h units to the right. Okay, we learned this before. You can see some pictures here. So we have this y is equal to x squared that you know of, and we are shifting it by 1 unit up, and then 2 units up, and then 2 units down. All right, so this is shifting up and down examples. And here's an example shifting to the right and to the left just once. Okay, sorry about that. And here you have the graph shifting to the right or to the left. If you're adding 3 like this, it is shifting plus 3, it's shifting to the left by 3 units. If you are subtracting 2, that would mean you are shifting to the right by 2 units, okay? These are examples. Now we have more coming. And here, this is absolute value function. We all like it. Absolute value function, you have absolute value of x, you are subtracting 2. That would mean we have to shift absolute value function, v function, to the right by 2 units. And then afterwards, you're subtracting 1 from it. That would mean you're going to shift it down, okay, vertical shift by 1 unit. Okay, so this is the nice graph. Next, we are going to be seeing more. We have vertical horizontal scaling and reflection. Okay, how would you do the reflection? So we have a constant c. We have a constant c. C is greater than 1. We call it a scalar. It's a number that we use for scaling. If you multiply the function with the scale c, and what it's going to do, it's going to stretch the graph f vertically by a factor of c. If you multiply it with 1 over c, it's going to be compression. Okay, it's going to compress the graph vertically by a factor of c. If you multiply x by c, then you're going to compress the graph horizontally by a factor of c. If you multiply x by 1 over c, you're going to be stretching the graph horizontally by a factor of c. On the other hand, if the c is special, if the c is -1, then it's going to reflect f across the x-axis, okay? If you're multiplying x with -1, it's going to reflect f across y, okay? All right, so let's move down. All right, let's see. You're going to see the examples here. So you're multiplying f, which is square root of x, which is the fishing rod function. If you multiply with 3, then it's stretching, okay, vertical stretching. And if you multiply this with 1 over c, which is 1 over 3, it's compressing the graph by 1 over 3, okay, by a factor of 3. And then we see these pictures as well. examples to the others. I want to show you the reflection. So we have square root of x. Okay, and let's see. We have square root of x here. We have a reflection of square root of x along the x-axis, which is negative square root of x. This is reasonable. And if you change x to negative
You're
x,
frozen.
then it's going to be a reflection along what? Am I?
You can't see. The stream is frozen.
Am I frozen? Am I frozen now?
The stream.
This is
Not
a nice
anymore.
question. Screen is frozen. Okay. Anyways, I think
Like there
everything
is
is fine. Just a sec.
20 to 25 seconds delay.
Give me 1 minute, okay? I just wrote here. Give me 1 minute. Okay. Okay. So it is 14 seconds delay when I talk. Is this what you
Yeah,
calculated
the
early?
screen. Yeah.
Oh my God. I know what the reason is. I had to move my connection to my upper, how to say, apartment. So I use some long wires. And as it gets longer, you know, we get this delays happening.
No, like more than 100
And-
meters, it will get slower. But less than 100 meters, it won't
But
get
it is
any.
less than 100 meters. But yeah, I know. But I thought so. But my the cable is like 100 meters actually that I use. I'm gonna cut it half because it's more than I need. I bought
Yeah.
just 100 meters to use, and then it's more than half, and I'm gonna cut it half. Maybe it's gonna save me some good internet connection.
Yes, hope so.
Okay.
Do you know how much?
Yeah.
Do you know how much is your download and upload speed?
I don't know. I didn't check. No. You can check if you want, but maybe after
Yeah.
class, let's check. Okay, if you have
Yes,
time,
yes.
of course.
Yes. Okay.
Let's talk about that after class. Okay.
Okay. Actually, they talk.
Yeah, Alexander.
Okay.
Yeah, Alexander has a similar problem, I guess. But actually, I did this between two houses. I have two houses, and I have one house doesn't have internet connection for some technical. They can't really do internet there for some reason. I don't know. And I had to get my internet from my other house. So it's just weird. I'm having this.
Do you have
issues these
TTNet
days.
or Super Online?
I have Türk Telekom.
So is it? Yeah, it must
I
be
have
Super
Türk
Online, I
Telekom.
guess. No, it's TTNet. Okay, whatever.
I
Let's
think
continue.
I ordered new wires. Okay, let's continue class. Okay.
We'll talk
So,
later.
anyways, now everybody knows my problem. Now everybody knows my problem. Anyways, okay. Okay. All right, so let's continue. Okay. Okay, so where are we at now? So these are polynomials we talked before. Okay, let's see. Yeah, polynomials of different orders. Okay, this is talking about the shifting. So A is the original f. Okay, B is the horizontal compression of f by a factor of 2. Look at that. The polynomial becomes different. Look, it has the 16 in the front now. Okay, because we multiply by 2, x by 2, so it's a different function now. Okay, and by a reflection across the y-axis. So we got a reflection first, reflection along the y-axis first, and then you're gonna do the horizontal compression by a factor of 2, then you get this picture, okay? And then let's see the vertical compression of y is equal to f of x in part by a factor of 2, followed by a reflection across the x-axis. So we are doing two transformations at once. So one, we are going to reflect it along x-axis, so it has to go upside down. Look, it goes upside down, right? And then we are going to do the vertical compression by a factor of 2 to get that. See, you can create, and look at the equation. The equation is not the same equation anymore, right? So you can play with it. You can play with it. You can create new functions by doing all these shifting stuff, okay? All right. And reflection as well. Trigonometric functions we are going to be talking about. So everybody knows what a radian is, okay? Okay, this is the definition of it. Okay, for a unit circle of radius r is equal to 1, the radian theta is the length of the arc AB that the central angle ACB cuts from the unit circle, right? So this is the circle. This is unit circle, and there's this angle we have theta, and theta is the length of this arc, this S we have here. Okay, that's the definition. So let's continue. There's a relationship between S and R. So what is S? What is R? Let's look at it again. So R is the circle of the radius. It's the bigger circle, R. This is the unit circle with radius 1. Unit circle means it's the circle with radius 1. And we have the angle theta. And in the radius, in the circle R, we have the this arc. This arc has the length S. And here, this arc has the length theta because of the unit circle. This is angle theta, but the arc it is also theta. Anyways, so theta has this relationship. Theta is equal to S over R. So S, R, and theta are proportional. Okay, this is what we conclude from here. So S is equal to R times theta. Theta is in radians. Okay, so we have the degrees and the theta radians converting to each other. So pi is equal to 180, you guys know. Pi over 2 is 90 degrees, etc. 2 pi is 360. You remember that from high school. And then, okay, and the angles of this is important for trigonometry. We have the initial ray, and this is the angle, this is the positive measure, and it's the direction if the angle goes through here. But if you go the other way around, it's the negative of the angle, okay? These are just standard information that you know from high school. For example, we want to draw 9 pi over 4. 9 pi over 4 is very big. So you have to turn all of it by once and then come back to pi over 4 degree here to get that. For example, 3 pi, it's bigger than 2 pi. You go once and you go pi more. And this is negative 3 pi over 4, it's just the opposite. And negative 5 pi over 2. Okay, so you're going to start here. You're going to turn 1 in the opposite direction, and you're going to come to pi over 2, negative pi over 2 in the opposite direction. Okay, and we have these relationships. And we have theta, we have right angle triangle, opposite adjacent, and hypotenuse. And we have sine theta is opposite over hypotenuse, you know. And cosine, you know, it's the reciprocal of the adjacent. I'm sorry, not yet. cosine theta is adjacent over hypotenuse, and tangent is sine over cosine. So you end up with opposite over adjacent. Okay, opposite over adjacent is the tangent theta, and then secant theta is 1 over sine. Since it's 1 over sine, it is just the reciprocal of this. Secant theta is the reciprocal of cosine. It is hypotenuse over adjacent. Cotangent theta is the reciprocal of tangent. It's adjacent over opposite. So let me write this reciprocal because maybe some students don't know. Let me write just one example. Cotangent theta. I'm going to write it like this. Cotangent theta is the reciprocal of what? Tangent theta. Okay, that's how we are going to write. Okay, reciprocal means you are flipping it over, 1 over that. You're taking the 1 over that. Okay. Some students may not know the. Okay, so then and then trigonometric functions of a general angle theta are defined in terms of x, y, and r. That's right. So we have the angle theta. We have so this is our unit. It's not a circle anymore. This is circle with radius r, and it has a radius r here. This is the distance x. This is the distance y, and then we use that to find the trigonometric angle values using that. And these are well-known triangles, right angle triangle. This is pi over 2 degrees, pi over 4, pi over 4. The sides are 1 square root of 2, right angle triangle. And this is 1 square root of 3, 2, right angle triangle. Or you can call it 30 degrees, 60 degrees triangle. You can also call it, this is pi over 4 triangle, right angle triangle, you can call it. These are common triangles we use often. And this is about the signs of the trigonometric functions as well. Here, all of them are positive, all of them. And here, only sine x is positive. Here, tangent is positive. Here, cosine is positive here, okay? And the rest are negative, okay? Here, the rest are negative except tangent. Here, the rest are negative except sine. Okay, so this is a recall. And in short, this, if you remember, look, this ASTC, you can just write it. All students take calculus. So all students take calculus. If you forget the sign, you can remember it. Okay, all students take calculus. Okay, ASTC rule. All right. Okay, so let's move on. What is this? This is an example. Let's say we want to find cosine 2 pi over 3. We want to find this point. Okay, so we are going to draw this right angle triangle here. And we have the x value here. This is the y value here. And we are going to cosine 2 pi over. So everything is negative except sine here. Okay, so cosine 2 pi over 3 is going to be definitely negative. Okay, and what is this angle here? Pi over 3. Cosine pi over 3 is adjacent over hypotenuse, so 1 over 2 over 1. So it's going to be 1 over 2, but the sign is negative. And then sine 2 pi over 3, sine is positive here because of ACTS rule. Okay, TC rule. All students STC rule. Okay, all students take calculus rule, and sine is positive here. Sine 2 pi over 3 is the same as sine pi over 3 here, and this is opposite over adjacent, opposite over hypotenuse, and square root of 3 over 2 over 1, and you get that. Okay, that's how you do it. Okay. All right, so this is a list that you can use when you're solving problems. You can check it here, or you can remember it. Okay, you can, because I introduced you that, recall that from high school. And we talked about the periodic functions, like for example, cosine and sine are periodic functions. What does it mean periodic? Is it only sine and cosine periodic? Maybe not, right? Maybe there are other functions that are periodic. And the rule mathematically is if you add p to x, you get the same function. So after 2 pi, you're going to get the same point for sine, for example. Okay, that's the definition. Okay, a function is periodic if there's a positive number p such that f of x plus p is equal to f of x for every value of x. Okay, the smallest such value of p is the period of f. So in this case, for cosine and sine, it's sine 2 pi. Okay, because 4 pi is going to give you the same, but we have to use the smallest one. For tangent and cotangent, we have the period pi. For sine, cosine, secant, cosecant, because they are related to sine and cosine, the period is 2 pi. All right, and then let's see, an even function, odd function, cosine and secant, which is secant is 1 over cosine, they are both even functions because cosine is even. On the other hand, sine, tangent, cosecant, cotangent, these are all odd functions. Okay, it's good to remember that. Okay, then let's see. Okay, these are the graphs of cosine, sine, and we did this before, and this is more clear. Look, for example, domain of cosine is everything, and the range is between -1 and 1. The period is 2 pi. This is the one wave that I meant. Okay, this is one wave for sine. Okay, and this is the one wave for tangent. The domain is just between the domain except pi over 2 powers, right? 3 pi over 2, but we have to exclude all these. These are asymptotes, okay? And then the period is pi. See, it repeats itself. The wave repeats itself every pi here, okay? And then we have secant x. Secant x looks like that. The domain is you have to exclude pi over 2 powers, like pi over 2, 3 pi over 2, 5 pi over 2, but the odd powers, of course. Not all powers. Like in here also, pi over 2 powers, but odd powers. 3 pi over 2, 5 pi over 2, etc. And cosecant is similar to that. And cotangent is similar to tangent, but it's the other way around, the graph. And it's not going to be defined at powers of pi, okay, here. And the period is pi again. So this picture, these graphs are good. And we have the reference triangle for a general angle theta, okay. This is the one that we discussed before when we are finding the example. Okay, you can consider this height as the absolute value of the sine theta because, right, here the absolute value of cosine theta. So if you move this theta here, you should always think about that. This height and width is going to be the absolute positive values. Okay, negative comes from where the point is located. If the point is here, and our right angle triangle, the point is going to have negative values here, but the length of the sides of this right angle triangle are all positive. Okay, that's why we have this picture. And then we have identities. These identities are trigonometric nice identities. Cosine squared plus sine squared is always 1. And we have this new form, maybe for some of you, 1 plus tangent squared theta is secant squared theta. You may verify them at home. You may verify them at home. Are you here with me or am I losing you?
No, we're here.
Yeah, we are here.
Okay. Thank you. These are maybe previous knowledge, but I have to recall. And I want you to verify this, like instead of tangent, write sine over cosine and square it. And then at this, you're going to see that you get this. Okay, it's a good practice. Do this at home. And then addition formulas, we have cosine A plus B is cosine A, cosine B minus sine A. You don't have to memorize this. You can take a look, okay? You can have a, for example, in the test, you can have a cheat sheet like this. You can write it somewhere and then use it. The formulas are, you can use them, okay? These type of formulas though, okay? And then double angle formulas, we have cosine 2 theta is equal to cosine squared theta minus sine squared theta. On the other hand, sine 2 theta is 2 sine theta cosine theta. These are useful as well. When you're doing integration, these are very useful, handy. And by using these, we can get half angle formulas. if you get, for example, isolate cosine squared from here, and instead of sine squared, if you write 1 minus cosine squared, etc., you get this formula. So these formulas comes from double angle formulas, okay? All right, so it's easy to get them. And we have this angle formula c squared. If you have if you have a triangle, and if one angle is known, if you have the sides A, B, C, then this is it is. So this is the angle triangle. Here's the A, B, C, the sides. And let's say you don't know C, but you know A and B, and you know theta. You can easily find C using the formula I just introduced. This formula.
Is it
okay?
cosinus formula?
To get C. Okay? Say it again.
Was it cosinus formula?
This is called law of cosines. Yeah, this is law of cosines. That's right. That's right. Remember right. Law of cosines. And then we have sine theta has this property. Actually, we know sine theta is between -1 and 1, but there is more to it. This is more. Sine theta is between absolute value of theta and negative of the absolute value of theta. Okay, this is more and very useful when we work with the limits. When we work with taking the limits, etc., this is going to be very useful. Similarly, this is going to be very useful when we are calculating the limits. Okay, also maybe in integration we may use that, but mostly this is useful. These are useful for when we do the limits. Okay, and then this is explaining why this is so. Okay, this is telling you about this inequality and why we get these inequalities. And I'm not going to get into details about that, but it is all geometry we get them from. Okay, and this is a summary of vertical stretch or compression. Look, y is a times f, b times x plus c plus d. This is containing everything inside. So vertical stretch or compression means you multiply f with a. Okay. Okay. And it's a reflection about y is equal to d. If negative, it says, if this is negative, a is negative, then you're getting a reflection about y is equal to d. That's what it says. And if you are changing x, if you're multiplying x with b, then it's horizontal stretch or compression. And if b is negative, okay, then it's a reflection about the x equal to negative c. And then if you're adding c to x, okay, it's horizontal shift. We talked about that, to the right or to the left, depending on c. And if you're adding d here, it's a vertical shift, shifting up or down. Okay, this is nice. Okay, so we have 10 minutes. We are going to skip that. We are not going to do that. And I think that's all to it here. Yeah, we are not going to do the graphing with calculator because we don't have enough time. Okay, I'm going to save it. And I'm going to move to, I can answer your questions maybe, or I can start my next slide in 10 minutes.
I've got a question.
Go ahead, please, Alex.
I've bought the book, the one you've told us, like the Pearson, and I'm waiting for it to come. And right now I'm at my lab math, and I was asking where can I find like the themas, like the subjects, so I can work on it at home.
Alex, can you say again? Sorry about the line.
I've purchased the book. I'm waiting for it to come. Right now I'm at my lab math, and where can I work on like on it, like on the subject, so I can cover some of the stuff.
Yeah, Alex, I sent the lecture notes many times. Probably your even if I add you to the group, maybe Microsoft doesn't accept your email address because it's Gmail. I don't know. Are you getting all of my emails?
I'm getting, yeah. I do get all your emails, like with the videos.
Okay, good. Because sometimes I also add your Gmail account separately because I'm not sure whether you're getting it, even if I edit your name to the group. Because last email I got from you, it sounded like you're not getting my emails. That's why.
No, I do get your emails. Sometimes they're just like coming in a few hours. Like if my friend gets it in 5 minutes, I get it like time after or something.
Okay, because of Gmail. Okay, all right. But you have your school's email, right? Did they give you, or what was the problem with your school email?
I've got my school email.
Okay, so fix it.
Everything
Okay,
is fine.
Alex, fix it. Fix it. It's very important. Okay, so yeah, fix your school's email. Everybody, I'm saying this to everyone. If you don't want to miss anything from any of your classes, please make sure that your school's email is working, because professors are using it quite often. You know. Okay,
As
let
I
me answer
understood,
some questions. If you're
I've got one more question. Like,
say it again.
I've got one more question. As I understood, the school email, it
Did you
works at
get the email?
Outlook.
Yes. Okay. Yeah. Yes. About the book, I have a question, Alex. Did you get the email access code from them?
Yeah, I did.
Did you register for MyLab?
Yeah, I did register for it, and yeah, I did.
Okay, probably, yeah, you can get e-text from there as well. There's e-text. I have not put the homework yet, but you can use the e-text there, okay? Instead, till your hard copy comes, because it may take your hard copy to come maybe a week or so, I don't know. Okay, just use the e-text over there, and e-text should be enough. And there are some questions at the end of the book, and I'm going to also put today homework questions. Maybe you can start working on the homework questions. While you're working on the homework questions, you're going to refer to the e-text, or maybe my lecture notes, and this should be help. You have these resources right now to work on.
Okay, then thank you.
Teacher, can
Okay,
I say
Atakan, you were saying something?
Teacher.
Yes, go ahead.
I can see
Go
chat
ahead.
box. I can't see chat box so that I can't write anything hi or bye.
What's your name again?
Beyza Çetin.
I have same problem, teacher.
Feyza Çetin. Okay, so what you're going to do is you're going to send me an email, and also you are going to send an email to this. Look, I'm gonna write this, and you're gonna CC me, okay? Just a second, let me write it here. Can you see my chat, even if you cannot write?
No, teacher, I can't see.
You cannot see the chat at all?
No.
Yes.
Can you try to
Okay.
send to her a private message in Teams? Does it work?
Feyza, try to send a private message. He's saying maybe you can. Does it not work either?
Okay, teacher, I will send an email about this problem.
Okay, I see that the stream is lagging really bad. Okay, Atakan is saying there's a PC version for that. I don't know. There were some other questions. Let me answer the questions in the chat. Yeah, you're talking about the e-text probably in the chat. There was a question from Bayram. I remember seeing it. Bayram had a question somewhere. I was gonna answer him. Okay, I cannot find it now. Let's see. Okay, if you don't have any other questions, it seems I couldn't find his question. Bayram, can you send your question again? You had a question at the beginning. I couldn't answer. Okay, anyways. Okay, we have 3 minutes. Study hard for your classes, and I will assign homework today to work on that, on the parts that we covered. Chapter 1. It's going to be over chapter 1. And chapter 2, we are going to start next class.
Will you send it on my MATLAB?
Okay. I'm going to send it on my MATLAB, and then I'm going to ask you to, if you work on the questions, just take the pictures of the questions, but not take the picture, I'm sorry, scan them as one PDF and put it as answers of homework 1 on LMS, okay? You have to write it in order, like question 1, answer this. Don't write the questions, but answer 1, answer 2, answer 3, because I want to see them in order. I don't want to just look around for question 5, okay? I want them to be in order. If you cannot answer a question, just write the number. Say you weren't able to do question 2, just leave it blank so that I see that you weren't able to do it. Okay? Be careful about that. That's what I want you to do. You're gonna do it on my lab, and then you're gonna write it down. You're gonna write down the solutions, and you're gonna scan them as one PDF file. If you don't do it one PDF file, I'm not gonna read it at all. Okay? I want one PDF file. You can do this by using your cell phone's free scanner apps. Okay? And just upload them. I'm gonna send you an access on LMS. Don't send them through email. Don't send through email. Okay, we are gonna do everything on LMS. Okay, that's what I want. And thank you for your cooperation. Okay? Okay.
Excuse me.
Bye-bye, take care. Go ahead.
They are chatting in the messages. They are asking you questions in the message section.
Okay, I didn't see this. Sorry about this. Let me go over. I only got the order confirmation mail from Çağlayan Kitabevi said. Exactly. And what's the question? Let me see. Can you read the question that you have seen? Teacher, I didn't get my exam. Aylin Gül. Okay.
Gül, yeah.
Okay, Aylin. Aylin Gül. Thanks. Aylin, what you're going to do is you're going to send me an email saying that you bought this. You're going to tell me the date you bought the book online. I mean, you ordered the book or e-text or whatever online. I need the date. And also you're going to say that you didn't get it for these many days. And I will forward it as it is to the publisher representative. And then they are going to look through it, okay? And also they are going to contact the bookstore and they are going to say, why are you, you should do it on time, blah, blah, blah, blah, you know, right? It is their job. They have to do it. Okay? So I need that information. Just send me an email and I will forward. And
sorry?
usually it takes just 1 day, they said. Go ahead.
When will you upload this lecture to YouTube? Because, you know, it was so lagging. Like,
okay, I see.
Like we need to repeat it. To watch it
okay,
again.
that's right. You're right. Sure. To upload it after class. Okay, I will upload it after class.
Will it be laggy again or no?
No, it's not lagging. It's not lagging.
Okay.
I checked it last time. It's not. Yesterday, for example, I had similar issue, and it wasn't lagging. I mean, because I'm the one always talking, and it just records my screen, so nothing really troublesome. Okay. Okay. Any other questions?
Teacher, I have a question.
Go ahead. What's your name?
Did you hear me? İsmet Gök.
Yes, I heard. What's your name?
İsmet Gök.
The name doesn't appear because of the lagging.
Yeah, okay. I didn't purchase the book or code yet. Is it problem for homework?
No, for it is just not good for your improvements. Like you're gonna start late in solving the problems, and it's gonna be just that my problem. But other than that, it's not a big problem. But try to get it ASAP. It's good for you.
Okay, teacher, thank you.
Any other questions? Okay. I need to get the attendance, by the way. I don't want to forget. Just wait. Don't leave. Let's see. Why doesn't it? Where is it? It's right here. Okay. Just a sec. I should be getting. No, it doesn't allow me to do that. Why not? It would do yesterday and last week. Okay, there's an issue with the teams. Usually I was able to get a list for the attendance, and it doesn't allow me to do that, and I wonder why. Okay, I hope this is not because of the connection. Let me try something else here. Oh my. Okay. Okay, I will report that. Yeah, about this not being able to use the chat. I mean, as well, it's a big problem. So we have two problems now on the chip, on the Teams. You cannot really write on the chat, and number two, I was able to take the attendance here, and now I can't. I don't know why. Okay, it's a problem. Okay. Okay, there's a comment here, I guess. Bye. Yeah, you should say bye, and maybe we can use the bye recordings to get the attendance.
Teacher, I'm here, but I can't write bye.
I mean, you should tell me you are Feyza, right?
Beyza Çetin.
Beyza. Okay.
Beyza
So I'm gonna write here, Beyza here, but not use chat.
Yes. I sent email, teacher, by the way.
Okay.
Teacher, can we leave now?
Please do that. You can. I'm just trying to get the attendance. Please leave. Thank you very much for coming. See you next
Teacher, I
time.
can't write something on chat box.
Me too, teacher.
What's your name?
I emailed you.
Give me your names. Sıla. Okay.
Yes,
And what?
teacher, I can't write.
Okay, Sıla and who else?
Kaan.
Okay, Kaan cannot use. Is it because of the cell phone use maybe?
I'm using computer, but I can't see.
What's your name?
Şule. Şule Sıray.
What's your name? Şule. Şule Sıray cannot use. Who else?
Teacher.
Yes.
Teacher. Can you get my name for absence list? I can't write.
Yes, what's your name?
Berke Yasan.
What's your name?
Berke Yasan.
Berke, okay. Yasan.
Teacher,
Okay.
Nehir Gümüş.
Nehir Gümüş, okay. Who else?
Teacher, I have the same problem.
What's your name? Give me names.
Erkut Oğuz.
Erkut Oğur, okay. And who else?
Gökhan Yiğit, teacher.
Too many people. Gökhan Yiğit. We have to report that actually. Okay, who else?
Anıl Düzgün Albayrak.
Anıl Düzgün. Bayrak. Okay.
Umut Muratan Kılıç.
Murathan Kılıç. Murathan Kılıç. Okay, anybody else? That's it, I guess. Okay. All right. See you next class. Take care. Bye-bye.
Yes.
Bye bye teacher.
Teacher.
Yes.
Didn't you say Erkut Oğur, right? My name is Erkut Oğuz.